Hi, this is Vijay Kumar, faculty in electronics. Today we are going to discuss PN junction diode in the easiest way, simple way, and it is very easy to understand. The students who are getting difficulty to understand the concepts, we can make them understand today. Okay, so what we are going to start the PN junction. The first thing is PN junction formation in a diode. So here the word diode is very familiar with us and everybody knows we are studying simply diode. So we have different types of diodes as we know, right? It's one part of that PN junction diode, and we know Zener diode, and we know Vector diode, and we know terminal diode, and LED, light emitting diode, photodiode. There are various types of diodes we are studying in our subject wise. But do we understand what is meant by diode? Why these devices named as diode? Diode is any meaning? Is there any meaningful word in English? No. So the diode is a combination of two words. Diode is the name combination of two different words. What are they? It is formed with two electrodes. Two electrodes. Whereas die is meant for two. ODE is the short form of electrode and they are attached together and they form a name diode. Okay, the device which is having two electrodes can be called as diode. Any device which is having two electrodes can be called as a diode. In this particular segment, we are studying PN junction diode. PN junction diode. So what does it mean? The two electrodes, that is a diode which is formed with the combination of P and N-type material. Whenever a P-type material is added with an N-type material or N-type material is added with a P-type material, there forms a PN junction. There forms a PN junction. We know. When you provide two electrodes for these two, then it is converted to PN junction diode. So here we know P-type material. The majority of charge carriers are holes and minority are electrons. In N-type, the majority of charge carriers are electrons and minority are holes. We know both the materials are extrinsic semiconductor materials. We know how it is formed. So, whenever a P-type material is added with an N-type material, so what will happen in the P-type material? There is a concentration of holes is greater than concentration of electrons, means the number of holes are greater than number of electrons, and compared to N-type, the number of electrons are greater than number of holes. But whereas coming these two different materials, so the holes and electrons in the P-type or tends to move towards N-type, and the electrons and holes in the N-type tends to move towards P-type. Why? Because there will be an attraction force acts between these two materials. There will be an attraction force acts between these two materials. So, let us suppose that tends to move towards P to N and N to P. So, if a charge carrier wants to move from P to N or N to P, they has to diffuse through the center of the material. Suppose in the N-type, there is an electrons. They want to move towards P-type. They has to diffuse through the P-type material at the center of this material. The same thing will happen with the holes and electrons moving from P to N. Okay. So, when these charge carrier transformation is happening at the center of the material, at a time, holes and electrons moving from P to N and N to P, at the same time, there is a chance of colliding some of the holes with some of the electrons or some of the electrons with some of the holes. Suppose a hole and electron collide with each other, there forms a neutralized region, so that at the center there forms a neutralized region by the collision of holes and electrons while moving from P to N and N to P. There forms a neutralized region which doesn't allow any attract or any repulsion at the center. Once the region forms, there is no transformation of holes and electrons. Movement occurs from P to N and N to P. So it acts as a barrier. So it restricts the transformation of charge carriers in the device, so that this particular formation is known as, what we are calling it as a PN junction. What we are calling it as a PN junction, or it can be called as a depletion layer. The other name for it is depletion layer, and it also can be called as potential barrier. Potential barrier. Depletion layer means the area depleted by the collision of holes and electrons while moving from P to N and N to P at the center of the P-type material is known as a depletion layer. So the moment of charge carrier across the center of this material we are studying usually in the form of drifting and diffusion. Okay, the charge carrier may diffuse, the charge carrier may drift. Okay, that is a different, and we can study in a core subject. This is a general easy understanding method what I am explaining you. So this is the way how the depletion layer forms, how the PN junction forms in a PN junction diode, so that it acts as a barrier and the device will act as an insulator. It doesn't allow any charge carrier transformation, so that there is no charge carrier movement occurs. So when there is no charge carrier movement occurs, the conductivity of the material is zero, so that the conduction is zero, so that the material behaves as insulator. The material behaves as insulator. To get conductivity across the junction, so that we have to apply some external additional supply. Okay, so to move the charge carrier. That's what we are explaining in next chapter, like forward bias and reverse bias.